So here's how you can do some more advanced integration by parts problems in Calculus 2. So let's say you have an integral like this, where you can't really do any u subs or anything like that, so you're going to have to use the integration by parts formula. So what you want to do is assign one of your variables here to u and the other one to dv. Now the one that you want to assign to u, you want to make sure it's a term that when you derive it, it will eventually become constant. Because what you're going to do is take the derivative of u, which is du, and you're going to take the integral of dv, which will give you v. So that's why you want to make sure that you assign your u to whatever's going to become constant. And just looking at this expression, I can tell that this x squared will eventually become constant if we take the derivative enough times. Now the derivative of sine is cosine. The derivative of cosine is negative sine. And so that's just literally going to keep looping between sine, cosine, sine, cosine. So we'll never get a constant with this. So we're going to set this piece to u. So in this case, I'm going to make this my u and then this my dv, which I'll set down here. Now what I'm going to do is take the derivative of this u term, which is we can do using this power rule. And if we use the power rule here, we should get 2x with respect to x. What I'm going to do is integrate that dv to give us v. And the antiderivative of sine is negative cosine. So I'll get the negative cosine of x. So this right here is my u, v, my du, and my dv. And what we can do is, since we are integrating this expression here, we can take all of these terms and plug them into this expression up here. So all you need to do is take these three variables and plug them in where you see them up here. The dv was just what we set to get our v term, which is negative cosine. So in this case, if I set everything equal to these expressions in the equation, I should end up with this expression right here. So this is what I end up with. I'm actually going to cancel this negative sign with this negative sign, and I'm also going to bring this negative sign out front. So we're going to end up with negative x squared times the cosine of x plus the integral of 2x cosine x dx. But now notice we run into another problem. We can't integrate this straight across because we don't have a way to u sub or anything, so we're going to have to use integration by parts a second time. So what I'm going to do is set this to u2, set this to dv2, and now we're going to use integration by parts again. So in this case, I need to take the derivative of u2, and that's just going to become 2 with respect to x. And then I take the integral of dv right here, and if I do that, I should get v2 as sine x. So now I can take these variables right here, and plug it into this expression where everything is now in terms of the second term. So if I plug everything into that equation, notice now that I'll end up with this expression. And I rearranged everything on this side so that way the du2 had the dx at the end and then the 2 at the front. So now I have this expression right here, which what I can do from here is I can actually simplify this into this expression right here by taking the 2 outside of the integral. And now what I can do is take the antiderivative of sine, which in this case is going to be negative cosine. But then I can cancel the 2 negative signs to give me this expression here. So I can take this expression and plug it back in for what I had for the integral, and that's going to give me this expression in total. So this right here is going to be the answer to this integral problem. So as you can see, it's definitely pretty tedious, but eventually if you just keep using this formula, you can usually get to an answer. And also here are the integrals and derivatives we used for the cosine and sine, but that is how you can do integration by parts for more complicated functions.